Wait. Before you throw away that ugly rock, watch this first. Every single day, amateur diamond hunters are tossing away fortune-bearing stones because they look absolutely worthless. I'm talking about 7 specific rocks that hide natural diamonds in plain sight, and you've probably walked past dozens of them. The diamond mining industry doesn't want you knowing this, but rough diamonds don't sparkle, they look like garbage. In this video, I'm revealing the exact host rocks, indicator minerals, and diamond identification techniques that separate professional gemstone prospectors from beginners. Your next river panning trip could change everything if you know what to look for. Let's find some diamonds. The 7 rocks and home testing. Now I'm going to deliver exactly what I promised. The complete breakdown of all 7 rock types that hide diamonds, plus the home testing methods that confirm your discoveries with certainty. Rock number 1, fresh Kimberlite. But here's the complete identification system. Fresh Kimberlite is blue-gray, has that sugary texture, contains visible mineral inclusions, feels heavy, and shows metallic luster on broken surfaces. The definitive home test, hardness evaluation of included minerals. Kimberlite contains olivine, and olivine has a hardness of 6.5 to 7 on the Mohs scale. Take a steel file, hardness 6.5, and carefully test the green mineral grains in your Kimberlite specimen. If they resist scratching from the file, you've confirmed olivine presence, a strong indicator you have genuine Kimberlite. But there's something even more important for diamond verification. Take that same specimen and examine it under bright light with your loupe. This is the technique that changed everything for me. Look for small translucent crystals that appear slightly greasy or resinous. These crystals should be harder than quartz. We'll test that in a moment. Rock number 2, weathered Kimberlite, yellow ground. Yellow ground is chemically altered Kimberlite that looks like yellow-brown clay or friable earth. Most prospectors throw this away immediately, assuming it's sediment. Wrong. Yellow ground forms when Kimberlite weathers in place, and diamonds are perfectly preserved through this process. Here's your identification sequence. Yellow ground feels soapy or greasy when wet, contains small garnet fragments and other resistate minerals, and shows unusual weight for clay-like material. The home test is simple but definitive. Take your sample, break it apart gently in water, and carefully pan the residue. Yellow ground breaks down easily in water, releasing any diamonds or heavy minerals it contains. Professional diamond miners specifically target weathered Kimberlite because it's easier to process than hard rock. You're looking for the same heavy minerals we discussed: garnets, chromium diopside, and of course diamonds. Rock number 3, Lamproite. Lamproite is the dark horse of diamond-bearing rocks, literally. It's darker than Kimberlite, ranging from dark gray to black, with prominent mica crystals throughout. The Argyle mine in Australia, one of the world's most productive diamond sources, is a Lamproite deposit. That tells you something about its importance. Your identification checklist: dark color, fine texture with visible phenocrysts, soapy feel on weathered surfaces, and substantial weight. The advanced recognition technique: look for lucite, a distinctive mineral that appears as white or gray rounded grains in Lamproite. Lucite is rare in most rocks but common in diamond-bearing Lamproites. The home testing protocol involves the same hardness tests we use for Kimberlite, plus one additional verification. Lamproite contains potassium-rich minerals that give it distinctive chemistry. While you can't test this at home without equipment, the presence of mica, lucite, and the overall dark appearance provides strong circumstantial evidence. Rock number 4, Eclogite xenoliths. Now we're getting into rocks that even experienced prospectors sometimes miss. Eclogite xenoliths are fragments of deep crustal rock brought up in Kimberlite eruptions. They're dense, green to reddish in color, and composed primarily of garnet and pyroxene. Here's what most people don't know. Eclogite xenoliths sometimes contain diamonds themselves. These rocks look completely different from Kimberlite. They're much harder, with a crystalline texture that resembles metamorphic rocks like gneiss. The key identifier is the presence of bright red to orange pyrope garnet, combined with green omphacite pyroxene. This specific mineral combination forms only under the high-pressure conditions where diamonds are stable. Your home test. Eclogite is extremely dense and hard. A piece should feel substantially heavier than granite of the same size. The hardness test shows both constituent minerals scratch glass easily, hardness 7+. If you find eclogite fragments in a known diamond area, you're potentially very close to primary deposits. Rock number 5. Peridotite nodules. Peridotite nodules are chunks of mantle rock brought to the surface by volcanic activity, the same volcanic activity that transports diamonds. These nodules are typically dark green to black, extremely dense, and composed primarily of olivine. They feel heavy and often show a slightly weathered, rusty surface from olivine oxidation. Here's the connection to diamond hunting. Peridotite comes from the same depth range as diamonds. When you find peridotite nodules in volcanic deposits, especially in association with Kimberlite or Lamproite, you're in geologically favorable territory. Some peridotite nodules contain small diamonds, though this is less common than in Kimberlite itself. The identification test is straightforward. Peridotite is dense, dark-colored, and contains abundant olivine. Scratch a fresh surface with a steel file. The green olivine crystals should resist. The rock should also show a distinctive granular texture when examined closely. Rock number 6. Alluvial gravel concentrates. This one isn't a single rock type, but rather a specific category of material that beginners often discard. In rivers and streams near diamond sources, you'll find mixed gravel composed of weathered rock fragments, heavy minerals, and potentially diamonds. This material looks like ordinary stream gravel, multiple rock types jumbled together, but its composition tells a different story. Wait until you see what happens next. When you pan this material correctly, the heavy minerals concentrate at the bottom. You're looking for an unusual abundance of garnets, chromium diopside, ilmenite, black, metallic heavy mineral, and sometimes diamonds themselves. The presence of multiple indicator minerals together signals you're in productive territory. Your home testing protocol: take your concentrated material and spread it on a white surface under strong light. Use your loupe to examine each particle systematically. Diamonds will show that distinctive greasy luster and crystal faces if present. The indicator minerals confirm you're processing material from diamond-bearing sources. Rock number 7. Serpentinized peridotite. The 7th rock type completes our collection, serpentinized peridotite. This forms when peridotite is exposed to water and heat, transforming the olivine into serpentine minerals. The rock becomes softer, develops a scaly or fibrous texture, and often shows distinctive yellow-green to dark green coloration with a silky or greasy luster. Here's why this matters for gemstone hunting. Serpentinized peridotite often occurs at the margins of kimberlite pipes or in the alteration zones of lamproite intrusions. When you find serpentinite in a region, it can indicate proximity to diamond-bearing intrusions. The identification characteristics: softer than peridotite, hardness 3 to 5 versus 6.5 to 7, distinctive silky or fibrous texture, yellow-green coloration, and a soapy or greasy feel. This rock is easy to scratch with a steel file, unlike fresh peridotite. That hardness difference is your primary home test. Advanced home testing methods. Now I'm going to show you exactly how to verify suspected diamonds using techniques you can perform at home with minimal equipment. This comprehensive validation system gives you confidence in your discoveries without expensive laboratory testing. Test 1. The hardness test. Diamonds are the hardest natural material at 10 on the Mohs scale. This is critical. A genuine diamond will scratch any other mineral, including corundum, sapphire, ruby, at hardness 9. Your practical field test uses quartz, hardness 7, and a silicon carbide file, hardness 9 to 9.5. Here's the step-by-step procedure. First, verify your suspected diamond is harder than quartz by attempting to scratch a quartz crystal or glass surface, hardness 5.5 to 7. A genuine diamond will scratch these materials effortlessly. Second, test whether your specimen scratches silicon carbide. Only diamond and laboratory-created diamond simulants like cubic zirconia can accomplish this. Important safety note: perform hardness tests on inconspicuous areas of your specimen to avoid damaging potential gems. The goal is confirmation, not destruction. Test 2. The transparency test. Genuine gem-quality diamonds are transparent to translucent, even when they appear colored. Industrial diamonds may be opaque, but if you found a clear or slightly colored crystal, transparency testing helps confirm your discovery. Hold your suspected diamond up to bright light. Sunlight works perfectly. Can you see light transmission through the crystal, even faintly? Genuine diamonds allow light to pass through their structure. Many diamond simulants like glass or zircon also pass this test, so transparency alone isn't definitive, but opacity in a clear-looking crystal immediately disqualifies it as a gem-quality diamond. Test 3. The thermal conductivity test. Diamonds have extraordinary thermal conductivity. They absorb and dissipate heat faster than almost any other material. Here's your simple home version of this test. Breathe on your suspected diamond, fogging its surface with moisture. Watch what happens carefully. The fog should disappear almost instantly from a genuine diamond due to rapid heat dissipation. Compare this to testing a piece of quartz or glass the same way. The fog persists noticeably longer on these materials. While not absolutely definitive, rapid fog dissipation combined with other positive tests strongly suggests you found a genuine diamond. Test 4. The specific gravity test. Diamonds have a specific gravity of 3.52, meaning they're 3.52 times denser than water. This distinctive density separates diamonds from most simulants. Your home setup requires only a sensitive scale, water, and a small container. Weigh your suspected diamond dry, recording the weight precisely. Then suspend it in water using a thin thread, ensuring no air bubbles attach to the surface, and weigh it again. The difference between dry weight and submerged weight divided into the dry weight gives you specific gravity. For a specimen weighing 0.10 grams dry and 0.07 grams submerged, the calculation is 0.10 divided by 0.10 minus 0.07 equals 3.33. That's close to diamond's 3.52 specific gravity, especially considering measurement limitations with small stones. Results between 3.4 to 3.6 strongly suggest genuine diamond. Test 5. The UV fluorescence test. Many natural diamonds fluoresce under ultraviolet light, typically showing blue fluorescence, though other colors are possible. You can perform this test using an inexpensive UV flashlight available for under $20. Take your suspected diamond into a dark room and illuminate it with UV light. Genuine diamonds often show strong blue fluorescence, though note that approximately 35% of diamonds show no fluorescence at all. A positive fluorescence result supports your identification. A negative result doesn't disprove it. Test 6. The acid test. Diamonds are chemically inert and completely resistant to acids. While I don't recommend casual acid testing due to safety concerns, this property explains why diamonds survive in alluvial deposits while surrounding materials dissolve away. If you're working with a specimen you suspect contains diamonds embedded in matrix material, careful acid treatment can remove carbonate or silicate matrix without affecting the diamonds. This should only be attempted with proper safety equipment and ventilation. Professional prospectors use this technique to clean specimens, revealing diamonds that were previously hidden. Test 7. The electrical conductivity test. Standard diamonds are electrical insulators, while certain diamond types and most simulants conduct electricity to varying degrees. Electronic diamond testers exploit this property, using thermal and electrical conductivity measurements to identify genuine diamonds. These testers cost $20 to $50 and provide quick, reliable results. They're the single most valuable tool for confirming suspected diamonds at home. The tester applies a small thermal pulse and measures the response. Genuine diamonds show characteristic thermal conductivity that triggers positive identification. Professional-grade testers can distinguish between natural diamonds, laboratory-created diamonds, and common simulants like cubic zirconia or moissanite. For serious diamond hunting, this investment pays for itself with your first significant find. Visual identification. Let's start with what you'll actually see in the field. The first host rock you need to recognize is Kimberlite, and this is the big one. Kimberlite is the primary source rock for most natural diamonds worldwide. But here's what surprises most people. Fresh Kimberlite looks like blue-gray volcanic rock with a distinctive texture that professional miners call saccharoidal, which just means it has a sugary appearance when you look at it closely. Here's the critical detail. Kimberlite has a specific metallic luster on freshly broken surfaces that sets it apart from ordinary volcanic rocks. When you crack open a piece of Kimberlite, you'll notice it contains visible fragments of other minerals, little inclusions of olivine, garnet, and sometimes mica that create a speckled appearance. The rock itself feels surprisingly heavy for its size because of its high density. But most Kimberlite you'll encounter isn't fresh, it's weathered. Weathered Kimberlite transforms into a yellow-brown or rust-colored rock that looks almost clay-like. This is where beginners make their biggest mistake. They see this altered, earthy-looking material and assume it's worthless sediment. Wrong. Weathered Kimberlite, called yellow ground by professionals, can still contain diamonds just as readily as fresh material. The weight test is your first verification tool. Pick up a suspected Kimberlite sample and compare it to a similar-sized piece of sandstone or limestone. Kimberlite should feel noticeably heavier. That's your first confirmation that you might have something worth examining further. The second host rock is Lamproite, and this one fools even experienced prospectors. Lamproite looks very similar to Kimberlite but has some key differences. It's typically darker, ranging from dark gray to almost black, and it has a finer texture overall. The metallic luster is less pronounced, but Lamproite has something Kimberlite doesn't: distinctive phenocrysts, which are larger crystals visible throughout the rock matrix. Look for small, shiny plates of mica that catch the light when you rotate the rock. Lamproite also feels greasy or soapy to the touch, especially on weathered surfaces. That tactile difference is something you'll learn to recognize instantly after examining just a few samples. Here's a critical comparison for you. Both Kimberlite and Lamproite are denser than common volcanic rocks like basalt or rhyolite. If you're examining a volcanic-looking rock near a known diamond deposit, always do the weight test first. A piece the size of your fist should feel substantially heavier than you'd expect. That's your green light to investigate further. Location strategy. Now here's where it gets interesting. Knowing what these rocks look like means nothing if you don't know where to find them. Let me explain the geological context in simple terms that will completely change how you approach diamond hunting. Diamonds form roughly 100 to 150 miles beneath the Earth's surface under extreme pressure and temperature. They only reach the surface through volcanic eruptions that bring up material from the mantle. These eruptions create vertical pipe-like structures that geologists call diatremes. This is critical. When you're searching for diamond deposits, you're really searching for the remnants of these ancient volcanic pipes. But there's something even more important you need to understand about diamond mining techniques and where to apply them. Most of these volcanic pipes have been eroding for millions of years. That means diamonds and their host rocks have been washing into river systems, spreading out across alluvial plains and concentrating in specific geological traps. This is why river diamond hunting can be so productive, not because you'll see diamonds sparkling in the current, but because rivers naturally concentrate heavy minerals, including diamond-bearing rocks, in predictable locations. Let me give you specific environments to target. First, look for areas where rivers change speed dramatically, where fast water suddenly slows down. These locations create natural traps where heavy rocks accumulate. Professional prospectors call these pay zones, and they're exactly where you want to focus your diamond panning efforts. Second, target the inside bends of rivers and streams. The physics of water flow causes heavy materials to concentrate on the inside of curves, while lighter materials wash away. If there are diamond-bearing rocks in the river system, this is where they'll accumulate over time. Third, and this is what most people don't know, look for exposed bedrock in streams. When you find bedrock with cracks, crevices, or potholes, stop and investigate thoroughly. These natural traps capture and hold heavy materials, including diamond-bearing rocks, that would otherwise wash downstream. Professional diamond hunters will spend hours carefully working a single bedrock exposure because they understand the concentration principle. Now let's talk about indicator minerals. These are your treasure map to potential diamond localities. The same volcanic eruptions that bring up diamonds also bring up other distinctive minerals. When you find significant concentrations of garnet, chromium diopside, or olivine in a stream, you're potentially close to a diamond source. Here's what to look for specifically: pyrope garnets that are deep red or purplish red in color. These aren't the brownish garnets you find in schist or gneiss. These are magnesium-rich garnets that form under the same high-pressure conditions as diamonds. If you're finding multiple pyrope garnets in your pan, you're in a geologically favorable area for natural diamonds. Chromium diopside looks like small bright green crystals. They're dense, they're distinctive, and they're a direct indicator that Kimberlite or Lamproite might be nearby. That's why you should never dismiss a location just because you don't find diamonds immediately. The presence of these indicator minerals tells you that diamond-bearing rocks have contributed to that sediment. Practical methods. Alright, let's get into the actual techniques you'll use in the field. I'm going to walk you through the practical methods that keep costs low while maintaining effectiveness. You don't need expensive equipment to start successful diamond hunting. You need knowledge and systematic approach. Your basic toolkit should include a classifier screen, quarter-inch mesh works well, a gold pan or specialized diamond pan, a small spray bottle filled with water, a magnifying loupe, 10 times magnification minimum, a magnet wrapped in a plastic bag, and some small containers for samples. Total investment? Less than $50 for everything. Here's your step-by-step process for diamond panning in a productive location. First, you classify your material. This means screening out everything larger than quarter-inch. Diamonds and their host rocks in alluvial deposits typically fall into the smaller size ranges, so you're focusing your efforts where they matter most. Second, you pan off the lighter materials using standard gold panning technique. Here's where diamond prospecting differs from gold panning. You're not looking for heavy metallic particles at the bottom of your pan. You're looking for rocks with that distinctive texture and appearance we discussed earlier. As you pan down your material, watch for those blue-gray or weathered yellow pieces that feel heavier than they should. Third, and this is critical, use your magnet to remove magnetic minerals. Wrap it in a plastic bag, pass it over your concentrated material, and discard everything that sticks. This removes magnetite and other magnetic minerals that can hide your target specimens. Professional prospectors know this step eliminates about 60 to 70% of unwanted material quickly. Now here's the technique that changed everything for me: the water spray test. Take your concentrated material after panning and magnetic separation, spread it thinly on a flat surface, and lightly mist it with water from your spray bottle. Watch what happens carefully. Kimberlite and Lamproite will often show that distinctive metallic luster when wet that completely disappears when dry. This wet-dry appearance change is a powerful identification tool that costs you nothing except observation. When you've identified a suspected diamond-bearing rock, here's your field extraction process. You want to carefully break the specimen using controlled force, not wild hammering. Place the rock on a solid surface, position a chisel or punch at natural fracture lines, and tap firmly but not excessively. The goal is to open the rock along its natural weaknesses without pulverizing potential diamonds inside. Here's a safety consideration most people overlook: always wear eye protection when breaking rocks. Sharp fragments can fly unpredictably, and protecting your vision is non-negotiable. Also, break rocks away from your concentrated panning material so flying fragments don't contaminate your sorted specimens. After breaking open a suspected host rock, examine the interior carefully with your loupe. You're looking for small, clear to slightly colored crystals with distinctive characteristics we'll cover in detail later. Even if you don't see obvious diamonds, keep the specimen if it shows the correct host rock characteristics. Some diamonds are small enough or positioned in ways that require more thorough examination at home. Advanced recognition. Let's move into advanced recognition techniques that separate successful diamond hunters from frustrated beginners. Understanding diamond shape variations and formations is critical because natural diamonds look nothing like jewelry store gems. Rough diamonds most commonly appear in these crystal forms: octahedrons, 8-sided, dodecahedrons, 12-sided, or irregular masses called macles. Here's the part that surprises most people. Many rough diamonds don't show obvious crystal faces at all. They're rounded, worn, or coated with surface materials that completely obscure their internal structure. The octahedral form is your most recognizable shape. Imagine two pyramids stuck together at their bases, but don't expect perfect geometry. Natural diamonds show all kinds of surface features: trigons, triangular markings, growth lines, and surface textures that range from glassy smooth to slightly frosted. Here's what to watch for specifically. Diamonds commonly have a slightly greasy or resinous luster on unbroken surfaces. Unlike quartz, which looks glassy, diamonds have this distinctive appearance that experienced prospectors learn to recognize instantly. When you're examining broken rock specimens, train yourself to notice this subtle luster difference. Now let's talk quality indicators, because not every diamond is worth pursuing. Gem quality natural diamonds are transparent to translucent with minimal inclusions visible to the naked eye. They might show color, yellow, brown, pink, or even rare blues and greens, but the crystal structure remains clear enough to transmit light. Industrial-grade diamonds, by contrast, are opaque, heavily included, or fractured. They still have value, but measured in tens of dollars rather than hundreds or thousands. Here's how you tell the difference in the field. Hold the suspected diamond up to strong light. Gem-quality material will transmit light, showing internal transparency even if colored. Industrial material blocks light transmission, appearing dark or completely opaque. Common mistakes that cause beginners to miss valuable discoveries? First, dismissing small crystals. A 2mm diamond might not seem impressive, but quality stones at that size can be worth $50 to $100 each. Find several in one location and you've had a genuinely productive day. Second, expecting perfect crystals. Natural diamonds are often etched, dissolved, or partially resorbed by the volcanic material that brought them up. These surface features actually increase confidence that you found a real diamond rather than a simulant. Third, and this is huge, throwing away weathered host rock. Remember that yellow-brown weathered Kimberlite we discussed? It looks like worthless clay to most people, but it concentrates diamonds just as readily as fresh material. Never dismiss a specimen based solely on its weathered appearance. Quality assessment and value determination. Now that you know how to confirm genuine diamonds, let's talk about quality assessment. Determining whether your find is gem-quality material worth significant money or industrial-grade material with modest value. The 4 C's of diamond grading apply to rough stones just as they do to cut gems: color, clarity, cut, in this case crystal form, and carat weight. Here's the part that surprises most people. Rough diamond assessment requires different considerations than graded cut stones. Color assessment. Gem-quality diamonds range from colorless, most valuable in white diamonds, through faint yellow or brown tints. Fancy colored diamonds, pinks, blues, greens, and intense yellows, command premium prices even as small rough stones. Hold your diamond against a white background under daylight-balanced light. Can you detect color, and if so, what type? Completely colorless rough diamonds are rare and valuable. Slight yellow or brown tints reduce value in white diamonds but don't eliminate it. Any strongly colored diamond, pink, blue, green, intense yellow, is potentially extremely valuable regardless of size. Clarity assessment. Examine your diamond with a 10 times loupe under strong light. Can you see inclusions, internal features like crystals, fractures, or clouds? Gem-quality diamonds have minimal visible inclusions. Industrial diamonds are heavily included to the point of opacity. Here's your practical classification. If your diamond appears transparent with no visible inclusions at 10 times magnification, you have potentially high-grade material. If you can see some inclusions but the stone remains mostly transparent, you have commercial gem-quality material, still valuable. If the stone is opaque or riddled with fractures, you have industrial-grade material worth considerably less. Crystal form. The shape of your rough diamond affects its potential value because cutting efficiency depends on crystal form. Octahedral crystals offer good cutting yield. Dodecahedral and irregular forms lose more material during cutting, reducing their per carat value. Perfect crystals are rare and desirable, but don't dismiss damaged or partial crystals. Even fractured diamonds have value if the fragments are clean and transparent. Professional diamond cutters can work with imperfect material